Good morning, Earth Science. It is Miss Novice here. I'm dropping a YouTube video to help explain the Sunpath lab and also two concepts in Earth Science, rotation and revolution. All right, so when you open up your worksheet, you're going to see this picture of suns, one directly above the other, and they're labeled June 21st, March 20th, and the last one is December 21st. The reason for that is that at different days of the year, you're going to notice that the sun is at different positions in the sky. Now, in winter, we get less sunlight. You might notice that the sun sets very early, like 4 o'clock or 5 p.m.-ish. And in the summer, like right now, I know it's supposed to be summer, the sun might set later, like at 8 p.m. or even 9 p.m. And the reason for that is that the Earth doesn't stay in one place in the solar system. The Earth has two motions, a rotation and a revolution, that causes the sunlight to change and causes the position of the sun to change. So let's take a look at these two motions. First one is called rotation. Now, I told the Earth Science class a joke today on Zoom. The joke is, did you know that the rotation of the Earth really makes my day? And it's a joke because the rotation of the Earth takes 24 hours, so one day. What a rotation is that we have the Earth, and the Earth is on an axis. And I drew this line tilted on purpose. This line, I exaggerated it a little bit so you could see it. It is 23.5 degrees from the vertical. It's tilted at 23.5 degrees. Remember that number. That number is going to be very important later in the week when we talk about the Tropic of Capricorn and the Tropic of Cancer, two places on the Earth where we get the sun directly over above. And I'm going to explain how that happens. But for now, just remember that the Earth is tilted at 23.5 degrees. And the Earth has a movement we call rotation, which is when the Earth spins on its own axis. And this takes 24 hours. Now, it takes 24 hours, and it's not a coincidence that it's 24 hours. It's because it's one day. We have a day and a night. We have maybe 12 hours day, 12 hours night. And the Earth does a complete cycle, does a complete spin on itself. There are other objects in real life that do rotations. For example, the wheels on a car. The tires, they completely spin in place. They revolve around an axis. Wheels revolve around an axis. If you take a basketball and you spin it on your finger, that's also rotation. So those are some other examples of rotation in real life. So rotation causes day and night, and is also present in other planets in our solar system, not just Earth. There are some planets that have a very, very long rotation, like Venus, whose rotation is 280 days, which is actually longer than it takes to go around the sun. It takes 280 days for the planet to just completely rotate on its own axis. It's crazy. And there are other planets that have a very short rotation, like Jupiter, which has a rotation of only 9 hours. It takes 9 hours for it to spin upon itself. But that doesn't explain why the sun would appear to be in different spots in the sky. Rotation explains why we have a sunrise and a sunset to begin with. If the sun rises at the horizon, goes above me at noon, and sets, that's because the Earth is doing this. The Earth is rotating, and if the sun is like right here, I'm going to draw a sun here. If the sun is down here, then this point in the Earth, this would be like noon. It's directly in front of the sun. Over here, the sun would appear to be rising. Over here would appear to be setting. So we have the sun would appear to change in our sky during the day, but that's just because the Earth is rotating. The position of the sun, how it changes from month to month, that depends on something else called a revolution, which is different than a rotation. So I'm going to draw a sun here. I'm going to give it some color. I have a big old orange sun. And I'm going to draw 4 Earths around the sun. Now I'm drawing the Earth with a tilted axis on purpose. And notice that this tilt doesn't really change. It's the axis pretty much always stays in the same tilt. The Earth just moves from one position to the other as it orbits around the sun. And this revolution, as you can guess, takes 1 year or 365 days. Actually 365.25 days. That's why we get a leap year every 4 years. But for all purposes, we're going to round it up to 365 days. Now, at this position over here, I have the Earth. It has this tilt, this 23.5 degrees tilt. And in my northern hemisphere, which would be this section that I'm going to shade in, I'm only worried about the northern hemisphere. It happens to be tilted towards the sun. If my Earth is tilted towards the sun, that's going to be a season that we call summer. Tilted towards the sun, we're getting more sunlight. It's going to be warmer. We're going to call that summer. And the first day of summer happens to be June 21st. It's coming up. It's next month. June 21st happens to be the first day of summer. And that is when the Earth is tilted the most towards the sun. From June 21st on, the Earth is going to move away from the sun so that both hemispheres, in this case down here, these two hemispheres are equally distant from the sun. This tilt is not really pointed towards the sun nor away from the sun. It's just kind of sideways with the sun. We call that an equinox. And I'm going to write the term down here. Equinox. After summer, we get fall or autumn. And the first day of autumn would be September 21st. Now, this is not an exact day. Sometimes the fall equinox is September 22nd, sometimes it's 23rd. I believe once in a blue moon it can be September 20th. I'm going to round up all these dates to 21st to make your life easier, but just know that every now and then the actual day can change, and that's going to depend on what year it is. After fall, we're going to have winter. Winter. On this Earth right here, the axis is tilted now in the northern hemisphere. In this hemisphere, the axis is now away from the sun. We're going to say that is winter. And the first day of winter is in December. And it's December 21st. And then after winter, we get spring. And spring, we've already been in spring for a while. Hasn't felt like that because it's been snowing. But in the northern hemisphere, we get spring on March 21st-ish. Sometimes it's the 22nd, sometimes it's the 20th, but I'm going to round up all these dates to the 21st so you get the general idea. And that gives you a full year. Now, the funny thing about this is that even though the tilt is towards the sun in June 21st in the northern hemisphere, this is actually what we call an aphelion, is when the Earth is the farthest from the sun, and this is actually a perihelion, which is when the sun is closest to the Earth. Now, it's kind of weird. The sun is closest to the Earth actually in winter, but we happen to have winter in the northern hemisphere because the axis is tilted away from the sun. But over here in the southern hemisphere, they have summer. Their seasons are flip-flopped. And their summers can be quite exceptional. They can be even hotter than our summers. And it's a little bit because this distance is shorter to the sun than this distance over here. This whole thing, this orbit, we're going to call this orbit a very special name. It's not a circle. It is an ellipse. And that's actually really, really important. Moving on in astronomy, we're going to start calling this orbit an ellipse. But for today, I just wanted to teach rotation and revolution so you can do this worksheet better. All right, let's review rotation and revolution doing a T-chart. Rotation, revolution. Rotation. One thing that we said this morning, and this is exactly a copy of the lesson that we did this morning on Zoom at 10 a.m. Rotation is when an object spins on its own axis. And a revolution is when one object goes around another. And another example of a revolution, it could be a moon around a planet. It could be another planet around the sun. It could be, what are some other good examples of revolution? Like a merry-go-round, objects going around like a focal point, that would be a revolution. Things that rotation and revolution cause, rotations cause day and night. It causes the sun to rise, to appear to rise, the sunrise, and for the sun to set, because it takes 24 hours. And a revolution causes the change in seasons, because it's taking the planet and taking it for a spin around the sun. It causes the change in seasons. It's a combined effect. It's a tilt of the earth that changes with its position around the sun, and the actual revolution that causes the change in seasons. It's not just one or the other. It's both. It's both the tilt and the actual revolution that causes the change in seasons. And the revolution takes, on Earth, it takes 1 year, 1 Earth year, 365 days. Hope you can see that. All right. So that is rotation and revolution. In your worksheet right now, you can go through the first page, read the directions and the introduction. And I'm going to scroll down here so I can read along with you. And you have 2 questions on the first page. Number 1, make a hypothesis of why do you think the sun has different altitudes at different times of the year? Hopefully by now you have an idea. And number 2, during which date does the sun appear to be larger in the sky? Ooh, I wonder why that is. Use the picture to tell me which of the 3 suns that you see in the picture appear to be larger. What might cause this apparent change in size? It might be somewhere in this lesson over here. So hopefully you can pause this video, take some notes, and I'll be back tomorrow with another YouTube video that will explain solstices and equinoxes. All right, have a good night.